हेलो एंड वेलकम टू माय यूट्यूब चैनल द अननोन मैथमेटिशियन। आज हम लोग लाप्लास ट्रांसफॉर्म का पार्ट 4 स्टार्ट करेंगे, जहां पे हम डिस्कस करेंगे अबाउट इनवर्स लाप्लास ट्रांसफॉर्म। तो हमारी इनवर्स लाप्लास ट्रांसफॉर्म की जो मोटिवेशन है वो हमारी बेसिकली लाप्लास ट्रांसफॉर्म से ही आती है। जैसे हम जानते हैं दैट लाप्लास ट्रांसफॉर्म ऑफ एफ टी इज इक्वल्स टू कैपिटल एफ एस। तो यहाँ से हम ये कह सकते हैं दैट L inverse of capital Fs is equals to Ft, and this is known as inverse Laplace operator. This L inverse is known as inverse Laplace operator. अब हम इस inverse Laplace transform की definition लिखेंगे और उससे समझेंगे। देखिए, if capital Fs be the Laplace transform of the function ft, that is L of ft is equals to capital Fs, then ft is the inverse Laplace transform of the function capital Fs and is written as ft is equals to L inverse capital Fs, where L inverse is called the inverse Laplace transformation operator. बहुत बेसिक वर्ड्स में डेफिनेशन लिखी है, तो इसमें बहुत ज़्यादा कुछ डिटेल में जाने की ज़रूरत नहीं, क्योंकि बहुत ही ज़्यादा बेसिक है ये। देखिए, अब हम लोगों ने जैसे डिस्कस किया था कुछ एलिमेंट्री फंक्शंस का लाप्लास ट्रांसफॉर्म। अब हम लोग डिस्कस करेंगे कुछ एलिमेंट्री फंक्शंस का इन्वर्स लाप्लास ट्रांसफॉर्म। देखिए, हम जानते थे कि लाप्लास ट्रांसफॉर्म 1 इज़ 1 बाय एस, राइट। तो यहाँ पे क्या हो जाएगा, लाप्लास इन्वर्स ऑफ 1 बाय एस इज़ 1। ये पहला हो गया, राइट। देन देखिए, हम लोग जानते थे दैट लाप्लास ट्रांसफॉर्म ऑफ ई रेज टू पावर ए टी इज़ 1 अपॉन एस माइनस ए। यहाँ पे हो जाएगा लाप्लास इनवर्स ऑफ 1 बाय एस माइनस ए इज ई रेज टू पावर ए टी। और हम ये जानते थे कि लाप्लास ट्रांसफॉर्म ऑफ टी रेज टू पावर एन इज़ गामा एन प्लस 1 बाय एस रेज टू पावर एन प्लस 1। अब ये गामा एन प्लस 1 तो कांस्टेंट है, तो हम इसको इधर भी ला सकते हैं। तो हम ये कह सकते हैं दैट लाप्लास इनवर्स ऑफ 1 बाय एस रेज टू पावर एन प्लस 1 इज टी रेज टू पावर एन गामा एन प्लस 1। मोरओवर, हम ये जानते हैं दैट लाप्लास ट्रांसफॉर्म ऑफ साइन ए टी इज इक्वल्स टू ए बाय ए स्क्वेयर प्लस एस स्क्वेयर। तो यहाँ से हम क्या कहेंगे दैट लाप्लास इनवर्स ऑफ 1 बाय ए स्क्वेयर प्लस एस स्क्वेयर इज इक्वल्स टू 1 बॉन ए साइन ए टी। सिमिलरली हम ये भी जानते थे दैट लाप्लास ट्रांसफॉर्म ऑफ कॉस ए टी इज इक्वल्स टू एस बाय एस स्क्वेयर प्लस ए स्क्वेयर। तो लाप्लास इनवर्स ऑफ एस बाय एस स्क्वेयर प्लस ए स्क्वेयर इज इक्वल्स टू कॉस ए टी। यहाँ पे ए कांस्टेंट था, इसलिए हमने ए को ऑपोजिट साइड भेज दिया, बट यहाँ पे एस कांस्टेंट नहीं बिहेव करेगा, तो इसलिए एस हम उधर नहीं भेज सकते। देखिए, ऐसे 1 अपॉन एस कॉस ए टी, राइट। लाप्लास ट्रांसफॉर्म ऑफ हाइपरबोलिक साइन ए टी इज इक्वल्स टू a by s square minus a square. Laplace inverse of 1 by s square minus a square is equals to 1 upon a hyperbolic sine at. Laplace transform of hyperbolic cos at. It is equal to s upon s square minus a square. So Laplace inverse of s upon s square minus a square is equals to hyperbolic cos a t. हम जानते हैं by first shifting property that Laplace transform of e raised to power a t hyperbolic cos a t is equals to s minus a upon s minus a का whole square minus a square। तो हम यहाँ से ये भी लिख सकते हैं ना कि लाप्लास इनवर्स ऑफ एस माइनस ए अपॉन एस माइनस ए का होल स्क्वायर माइनस ए स्क्वायर इज इक्वल्स टू ई रेज टू पावर ए टी हाइपरबोलिक कॉस ए टी, राइट। हमने यहाँ पे क्या अप्लाई किया, हमने यहाँ पे फर्स्ट शिफ्टिंग प्रॉपर्टी अप्लाई की है। इसी तरीके से हम ये भी लिख सकते हैं क्योंकि लाप्लास ट्रांसफॉर्म ऑफ ई रेज टू पावर ए टी साइन बी टी सपोज, तो इसका क्या आ जाएगा, इसका आ जाएगा बी अपॉन एस माइनस ए का होल स्क्वायर प्लस बी स्क्वायर। तो यहाँ से ये लिख सकते हैं कि लाप्लास इन्वर्स ऑफ 1 अपॉन एस माइनस ए का होल इन्वर्स एस माइनस ए का होल स्क्वायर प्लस बी स्क्वायर, इसकी वैल्यू आएगी 1 अपॉन बी ई रेज टू पावर ए टी साइन बी टी। तो ये थे हमारे कुछ एलिमेंट्री फंक्शंस के इन्वर्स लाप्लास ट्रांसफॉर्म। अब हम लोग एक बहुत इंपॉर्टेंट प्रॉपर्टी इन्वर्स लाप्लास ट्रांसफॉर्म की सेम लाइंस पे डिफाइन करेंगे जैसे कि हमने लाप्लास ट्रांसफॉर्म में लीनियरिटी प्रॉपर्टी अप्लाई की थी, वैसे ही हमारी इन्वर्स लाप्लास ट्रांसफॉर्म पे भी लीनियरिटी प्रॉपर्टी होती है। स्टेटमेंट देखिएगा इन्वर्स लाप्लास ट्रांसफॉर्म की लीनियरिटी प्रॉपर्टी का, दैट इफ capital F1s and capital F2s respectively be the Laplace transform of functions f1t and f2t, यानी कि Laplace transform of f1t is equals to capital F1s and Laplace transform of f2t is equals to capital F2s, then it follows that Laplace inverse of, and C1 and C2 be the two constants, C1 capital F1s plus C2 capital F2s is equals to C1 Laplace inverse of F1s plus C2 Laplace inverse of F2s, which is equals to C1 L inverse F1s is equals to F1t plus C2, this is equals to F2t. So it is very similar, almost completely similar to the linearity property of the Laplace transform. Nothing more, nothing less. Now let's move to a very good question, that evaluate Laplace inverse of 3s minus 2 upon s raised to power 5 by 2 minus 7 upon 3s plus 2. Now look, we know that Laplace inverse of 1 upon s raised to power n plus 1 is equals to t raised to power n by gamma n plus 1, right? I think no problem will be made if we replace n plus 1 by n. So यहाँ पे हो जाएगा t raised to power n minus 1 upon gamma n. तो हम लोग सबसे पहले क्या करते हैं, यहाँ पे इसको लिखते हैं L इनवर्स ऑफ 3s minus 2 by s raised to power 5 by 2 minus s by 3s plus 2. Now this is equals to L inverse, इसको डिवाइड कर देते हैं, यानी कि 3s अपॉन s 5 by 2 minus 2 upon s 5 by 2 minus 7 by, यहाँ से 3 कॉमन करने हैं, 3s plus 2 by 3, यहाँ से हमारे पास आ जाएगा L इनवर्स 3 अपॉन s रेज टू पावर 3 बाई 2 माइनस 2 अपॉन s रेज टू पावर 5 बाई 2 माइनस 7 बाई 3 1 अपॉन s plus 2 by 3. Now using this result we can write this as Laplace inverse thrice of Laplace inverse 1 by s raised to power 3 by 2 minus twice Laplace inverse 1 by s raised to power 5 by 2 minus 7 by 3 Laplace inverse of 1 upon s plus 2 by 3. Now this is equals to, here n is equals to 3 by 2, so t raised to power 3 by 2 minus 1, which will be t raised to power half upon gamma 3 by 2 minus 2 times. Now here n is equals to 5 by 2, so t raised to power 5 by 2 minus 1, which is equals to t raised to power 3 by 2 upon gamma 5 by 2 minus 7 by 3. We know that L inverse of 1 upon s minus a is equals to e raised to power at. So here our a is minus 2 by 3. S minus 2 by 3. So it will give us e raised to power minus 2 by 3 t. So now by using the property of gamma function, we can write this as 3t raised to power half. It would be half gamma half minus 2t raised to power 3 by 2, 5 by 2 gamma 3 by 2 minus 7 by 3 e raised to power minus 2 by 3 t. Now 3t half upon half, gamma half is root pi, minus twice t raised to power 3 by 2 upon 5 by 2. Gamma 3 by 2 can again be written as 1 by 2 gamma 1 by 2. So 1 by 2 gamma 1 by 2 is root pi minus 7 by 3 e raised to power minus 2 by 3 t. I am sorry, I just committed mistake here because यहाँ पे हमारे पास 3 आएगा. 3 by 2 gamma 3 by 2. 3 by 2 half रूट पाई, बिकॉज जो गामा n प्लस 1 होता है उसकी वैल्यू होती है n गामा n. तो यहाँ पे हमारे पास n प्लस 1 में अगर हम इसको n प्लस 1 लिखेंगे तो ये 3 by 2 आएगा. तो यहाँ पे आएगा 3 by 2 गामा 3 by 2 और गामा हाफ जो होता है उसकी वैल्यू होती है रूट पाई. जब इसको थोड़ा सा अरेंज करेंगे तो ये आ जाएगा 6 और t हाफ अपॉन रूट पाई माइनस 2 2 ज़ा 4 2 ज़ा 8 by 3 t raised to power 3 by 2 upon root pi minus 7 by 3 e raised to power minus 2 by 3 times t, and this would be the answer. This is our next question. Evaluate Laplace inverse of 3s square minus 1 whole square upon 2s raised to power 5 plus 4s minus 18 upon 9 minus s square plus s plus 1 2 minus root s by s raised to power 5 by 2. Now, what are we going to do? First of all, let's open this square term. So this will give us L inverse 3 times of s raised to power 4 plus 1 minus 2s square upon 2s raised to power 5 plus 4s by 9 minus s square minus 18 by 9 minus s square plus we will multiply each term, so it will give us 2s minus s raised to power 3 by 2 plus 2 minus root s upon s raised to power 5 by 2. L inverse 3 by 2 s4 by s5 1 by s plus 3 by 2 s raised to power 5 minus 3 upon s cube plus 4s by 9 minus s square. Taking minus common from here, we will get 18 by s square minus 9 plus 2 upon s raised to power 3 by 2 minus 1 by s plus 2 upon s raised to power 5 by 2 minus 1 by s square. All good? Yes. Now we are going to use two known results, that is L inverse of 1 upon s raised to power n is equals to t raised to power n minus 1 by gamma n, and this is L inverse of s by s square minus a square is equals to hyperbolic cos at. Because look at here, if we take minus common from here, we will get 4s by s square minus 9, and it is very similar, almost completely similar to this. But here 18 by s square minus 9, we are going to use the inverse Laplace transform of 1 upon s square minus a square, which comes out to be 1 by a hyperbolic sine 80. Let me write this here. 1 L inverse of 1 by s square minus a square. This is equals to 1 by a hyperbolic sine 80. So we have these three results, and let's apply the required to each term. So here L inverse 3 by 2 comes out 1 by s plus 3 by 2 L inverse 1 upon s raised to power 5 minus 3 L inverse 1 upon s cube. Let me take minus common from here. Minus 4s by s square minus 9 plus 18 upon s square minus 9. Let me apply L inverse. L inverse plus twice of L inverse 1 by s 3 by 2 minus L inverse 1 by s plus 2 L inverse 1 upon s raised to power 5 by 2 minus L inverse 1 upon s square. So I've written this completely clearer. So now 3 by 2 L inverse, what is L inverse of 1 by s? It is 1 plus 3 by 2 L inverse L inverse L inverse of 1 by s raised to power 5. It is equals to t raised to power 4 by gamma 5 minus 3. What is L inverse of 1 by s cube? It is equals to t square by gamma 3 minus 4. Now look here, s upon s square minus 9. If we compare it by L inverse of s upon s square minus a square, a is equals to 3. So L inverse of s upon s square minus 9 is hyperbolic cos 3t plus 18. Now look here, L inverse of 1 upon s square minus 9. What is the L inverse of 1 upon s square minus a square? It is 1 upon a hyperbolic sine 80. And here the value of a is 3. So this will be 1 upon a. What is a? A is 3. Hyperbolic sine 3t plus 2. L inverse of 1 upon s raised to power 3 by 2. This will be twice of t raised to power half upon gamma 3 by 2 minus L inverse of 1 by s. It is 1 plus 2 L inverse of 1 by s raised to power 5 by 2. This would be t raised to power 3 by 2 upon gamma 5 by 2 minus L inverse of 1 by s square. This will be t upon gamma 2. Now let me solve it more. 3 by 2 minus 1. This will be 1 by 2. 3 by 2 t raised to power 4 by gamma 5 is 4 factorial minus 3t square upon gamma 3 is 2 factorial minus 4 hyperbolic cos 3t plus 6 hyperbolic sine 3t plus 2 t raised to power half upon gamma 3 by 2 is 1 by 2 gamma 1 by 2. 1 by 2 gamma 1 by 2 is root pi, and we have solved minus 1 with this plus 2 t raised to power 3 by 2. Gamma 5 by 2 is 3 by 2 gamma 3 by 2. Gamma 3 by 2 is half gamma 1 by 2. Gamma 1 by 2 is root pi, and minus t upon gamma 2 is 1 factorial, so it is 1 basically. Now 1 by 2 minus t minus 3 by 2 t square plus 4 factorial, 4 into 3 into 2 into 1. 3 cancels with 3, so we are left with 4 into 2 into 2. 4 4s are 16. So 1 by 16 t raised to power 4. Here it will be 4t raised to power half upon root pi, and here it will be plus 8 by 3 t raised to power 3 by 2 upon root pi minus 4 times hyperbolic cos 3t plus 6 times hyperbolic sin 3t. So this is our final answer. Now let us do some very different question like this. Evaluate Laplace inverse of 1 upon s cos 1 by s and Laplace inverse of 1 by s sin 1 by s. I'm going to attempt just this, and it's my advice to attempt this by yourself, L inverse of 1 by s sin 1 by s. But even before solving this, let me make sure that you know about this series of cos x, which is equals to 1 minus x square by factorial 2 plus x raised to power 4 by factorial 4 minus x raised to power 6 by factorial 6 plus so on. So what am I going to do is to expand this cos 1 by s in form of this. Using this series, I'm going to expand this cos 1 by s. Now L inverse of 1 by s. Here our x is 1 by s, so it is 1 minus 1 by s whole square by factorial 2 plus 1 by s whole power 4 upon factorial 4 minus 1 by s whole power 6 by factorial 6 plus so on. Now L inverse 1 by s minus 1 by factorial 2 1 upon s cube plus 1 upon factorial 4 1 upon s raised to power 5 minus 1 upon factorial 6 1 upon s raised to power 7 plus so on. Now we are going to apply the linearity property. L inverse 1 by s minus 1 by factorial 2 L inverse 1 by s cube plus 1 by factorial 4 L inverse 1 by s raised to power 5 minus 1 by factorial 6 L inverse 1 by s raised to power 7 plus so on. Now what is L inverse of 1 by s? It is 1. 1 by factorial 2. What is L inverse of 1 by s cube? It is t square by factorial by gamma 3 plus 1 by factorial 4. L inverse of 1 by s raised to power 5 is t raised to power 4 upon gamma 5 minus 1 by factorial 6. L inverse of 1 by s raised to power 7 is t raised to power 6 by gamma 7 plus so on. Now since gamma n plus 1 is n factorial, 1 by 2 factorial, t square gamma 3 is 2 factorial, so this will be squared plus 1 by 4 factorial t raised to power 4 gamma 5 is 4 factorial, this will be squared minus 1 by 6 factorial t raised to power 6 upon gamma 7 is 6 factorial, this will be squared plus so on. This is the final answer, and this is the Laplace inverse of 1 by s cos 1 by s. In order to solve the second part, that is Laplace inverse of 1 by s sin 1 by s, you will be required the series of sin x, which is equals to x minus x cube by 3 factorial plus x raised to power 5 by 5 factorial minus x raised to power 7 by 7 factorial plus so on. Now just expand this sin 1 by s using this and you will get your desired result. Now let's do one more question. Evaluate Laplace inverse of 1 upon s cube plus 1. हमें यहाँ पे कुछ ऐसा s के टर्म्स में कुछ दिख नहीं रहा है कि हम उसको फर्दर डिवाइड करते जाएं फ्रैक्शंस में और हमारा सॉल्व हो जाए ये चीज़, और इस फॉर्म का हमारा कोई फॉर्मूला भी नहीं होता, किसी एलिमेंट्री फंक्शन का लाप्लास इन्वर्स भी ऐसा नहीं होता है। तो चलिए हम देखते हैं क्या कर सकते हैं। एल इन्वर्स ऑफ 1 अपॉन एस क्यूब प्लस 1, यहाँ पे हम क्या करने जा रहे हैं, हम करेंगे यहाँ से एस क्यूब को कॉमन कर लेंगे, तो हमें क्या मिल जाएगा 1 प्लस 1 by s cube. This will be written as L inverse 1 by s cube 1 plus 1 by s cube का इन्वर्स। अब हम इसको बाय यूजिंग बायनोमियल थ्योरम इसको एक्सपैंड करेंगे। एल इन्वर्स 1/s³ 1 माइनस 1/s³ प्लस 1/s³ का स्क्वायर माइनस 1/s³ का होल क्यूब प्लस 1/s³ की होल पावर 4 minus so on, because 1 plus x raised to power minus 1 is equals to 1 minus x plus x square minus x cube plus x4, so on. So here now this could be written as L inverse 1/s³ minus 1 by s raised to power 6 plus 1 by s raised to power 6 multiplied by s raised to power 3, this will be s raised to power 9 minus 1 upon s raised to power 9 multiplied by s raised to power 3, 9 plus 3 is 12, s raised to power 12 plus 1 upon s raised to power 15. Here we are getting the multiples of 3, right, as the powers of is in the denominator. So L inverse, use the linearity property, s cube minus L inverse 1 upon s6 plus 1 plus L inverse 1 upon s raised to power 9 minus L inverse 1 upon s raised to power 12 plus L inverse 1 upon s raised to power 15 minus so on. Now L inverse of 1 by s cube is t square by gamma 3 minus L inverse of 1 upon s raised to power 6 is t raised to power 5 by gamma 6 minus t raised to power 8 by gamma 9 minus t raised to power 11 by gamma 12 plus t raised to power 14 by gamma 15 minus so on. This is t square. What is gamma 3? It is 2 factorial minus t raised to power 5. What is this? 5 factorial minus t raised to power 8. Gamma 9 is 8 factorial plus t raised to power 11. Gamma 12 is 11 factorial plus t raised to power 14. Gamma 15 is 14 factorial minus so on. This is the required result.